Look at your hand. Seriously, look at it. That hand almost entirely empty space. If you squeeze the empty space out of every human on Earth, all 8 billion of us, we'd fit inside a sugar cube. And we would also be the same weight, simply because atoms, which make up all ordinary matter, including you, me, and everything we touch, are roughly 99.9999% empty space. You've also never actually touched anything, ever. Time travel is literally a proven thing, and the universe might not fully exist until someone looks at it. After this video, you are going to understand more about the universe and our world than most adults ever will. All of it true. All of it proven. Explain like you're 2 years old. Part 1. What is stuff made of? What is everything made of? Your chair, this screen, you. What's the actual answer? Atoms. You've heard this word, but nobody ever shows you what an atom looks like. Probably because if they did, you would feel unsafe for the rest of your life. Here, I'll show you. Okay, imagine an atom is the size of a really big sports stadium. Massive. 90,000 seats. The biggest one you can picture. In the middle of the pitch, right in the center, there's a marble. That's the nucleus. The core of the atom, the electrons, the little bits flying around, are out in the car park, outside the stadium, in the rain, far away. And everything between the marble and the car park? Nothing. Empty. Just air. Just space. That's an atom. A marble in the middle of a stadium. That's it. That's all you are. The actual matter inside you, the stuff that has any physical substance, is so small that it's almost nothing. The rest is void. If you remove the empty space from every atom in your body, all the remaining matter would be smaller than a grain of sand. You would still weigh 70 kilograms. You'd just be invisible to the naked eye. Your ego would take longer to shrink, presumably. So why do you feel solid though? Why doesn't your hand fall through the table? Okay, you know how two magnets sometimes push each other away, even when you haven't touched them yet. Your hand does that. The tiny pieces on the outside of your hand, the electrons, they push against the electrons on the table really hard, instantly, and you feel that as solid. That pushing force, that electromagnetic repulsion between electrons, is what touching actually is. Your hand and the table's electrons never meet. They just scream at each other from a very small distance. You have never, in your entire life, touched anything. Every hug, every handshake, every time you've held something, electromagnetic screaming, all of it. This information has ruined physical affection for several physicists. Condolences. Now, what's inside the marble? What's in the nucleus? Okay, inside the marble there are even tinier things called protons and neutrons. And inside those are even tinier things called quarks. Quarks are the smallest things we've ever found. There's nothing inside them. They're the last layer, the very bottom. And physicists named the 6 types of quarks in a way that suggests they were having a drink too many. Up, down, charm, strange, top, bottom. These are the official scientific names, published in peer-reviewed journals, cited at international conferences. Charm and strange are real words that serious physicists say to each other with straight faces. I find this deeply comforting. A proton is 2 up quarks and 1 down quark. A neutron is 2 down and 1 up. And the entire periodic table, all 118 elements, everything from hydrogen to uranium, is just different counts of these same quarks, arranged differently. It's like Lego. You've got like 6 types of bricks, and literally everything in the universe is just those 6 bricks stacked in different ways. Stars, mountains, pizza, you. Just quarks, arranged differently. And here's the part that genuinely moves me every time. The iron in your blood, the iron that carries oxygen right now, keeping your brain alive, keeping you here watching this, wasn't made on Earth. It was made inside a massive star. That star ran out of fuel, collapsed under its own gravity, and exploded, hurling its guts across the galaxy. Billions of years later, some of that debris became our solar system. Some became Earth. Some became the food you ate. Some is in your blood right now. You are, scientifically and literally, made of stardust. Carl Sagan was not being poetic. He was doing chemistry. Part 2. The 4 things that make everything happen. Okay, we've got particles, but particles on their own just sit there. They need something to make them push, pull, stick together, explode, forces. And here's the ridiculous, beautiful, insane thing. Every single event that has ever happened, every explosion, every heartbeat, every star being born, every galaxy colliding, every thought you've ever had, all caused by one of exactly 4 forces. 4. That's the whole list. The universe has 4 controls, and that's it. My TV remote has more buttons than the universe's fundamental operating system. I don't know what to do with that information. Let me introduce all 4. After this, you'll understand the complete skeleton of physics. Number 1, gravity, okay? You know when you drop something and it falls down? That's gravity. Gravity is like an invisible hand that pulls everything toward everything else. The bigger something is, the harder it pulls. Gravity holds the moon around Earth, holds Earth around the sun, holds galaxies together. It works everywhere, reaches across any distance, and never turns off. It is also, and I want to be honest with you, hilariously, embarrassingly weak. Here's proof. This fridge magnet is fighting the whole Earth. The entire planet is pulling it down. And this tiny little magnet is winning. A fridge magnet beats the gravitational pull of a 6 sextillion-ton planet every single time. Gravity is the friendliest, most familiar force in your life, and it is absolutely the most pathetically weak. Gravity's only advantages are infinite range and never switching off. Given enough mass and enough time, though, it builds everything you've ever seen. Slow and steady, etc. Number 2, electromagnetism. Okay, you know what light is? And electricity. And why magnets stick to things? That's all the same force. It's called electromagnetism, and it is basically running your entire life. Chemistry, the thing that makes molecules, makes food, makes your body work, is electromagnetism between atoms. The neurons firing in your brain right now are electrical signals. The light hitting your eyes is an electromagnetic wave. Wi-Fi is an electromagnetic wave. Your microwave is an electromagnetic wave. Light, heat, Wi-Fi, X-rays, microwaves, they're all the same thing. Just different speeds of wiggling. Like the same song played at different volumes. Your microwave and a hospital X-ray machine are technically cousins. Your microwave is just a friendly cousin who heats your leftovers instead of photographing your skeleton. Number 3, the strong nuclear force. Okay, here's a problem. Inside every atom, the nucleus has lots of protons crammed together. And protons all have the same electric charge. And same charges push each other away really, really hard. So why doesn't every atom explode immediately? Because there's another force, the strong force, that grabs the protons and goes. And oh, you stay right here. And it's so strong that even all that pushing can't overcome it. The strong force is about 100 times more powerful than electromagnetism. It is the strongest force in existence. The catch, it only works at distances smaller than an atomic nucleus. One tiny step outside that range and it vanishes, gone, zero. The most powerful force in the universe only works at one specific address and has absolutely no interest in anything beyond it. Nuclear bombs and nuclear power plants work by releasing the energy stored in the strong force. You crack the nucleus open and all that pent-up energy comes out. That's where it comes from, not magic. Strong force. Number 4, the weak nuclear force. This one is sneaky. It doesn't push or pull. It transforms things. It can change one type of quark into a different type, which changes a neutron into a proton, which releases energy. This is called radioactive decay. And it's also why the sun shines. The sun is constantly squashing hydrogen atoms together so hard that they fuse into helium. The weak force makes the first step of that happen. Without it, the sun goes off. Earth freezes. Nothing lives. Fact, every warm sunny day you've ever had, every plant, every animal, every piece of food you've ever eaten, all powered by the weak nuclear force working inside the sun, 150 million kilometers away. 4 forces: gravity, electromagnetism, strong nuclei, weak nuclear. That's the complete control panel, nothing else. The universe, in its entirety, runs on those 4 things. Part 3, time is broken, and your phone knows. Okay, I need to tell you about time. And I'm going to need you to trust me, because your brain is going to fight this the whole way. Your brain evolved to hunt things and avoid being eaten. It did not evolve to understand physics. So when I tell you what time actually is, your brain is going to say no. Please override it. Okay, you know how when you're having fun, time goes really fast. And when you're bored, it goes really slow? What if I told you time actually goes at different speeds? Not just feels like it, actually does. In 1905, Albert Einstein, 26 years old, working a regular desk job at a patent office, reviewing other people's boring inventions, spent his evenings quietly dismantling our entire understanding of reality. He was 26. He had a day job. He did this in his spare time. Some of us struggle to read one book a month. I'm not making comparisons. I'm just saying. Einstein was thinking about light. He asked, what would a beam of light look like if you could run alongside it at the same speed? Based on the physics at the time, the light wave would appear frozen, standing still next to you. But a frozen light wave makes no physical sense. It can't exist. So Einstein made a wild decision. Instead of questioning the answer, he questioned the assumption. What if the speed of light is always the same for everyone, no matter how fast they're moving? Okay, imagine you're on a train throwing a ball forward. To someone standing outside, the ball is going train speed plus ball speed. That's normal. That's how everything works. But light doesn't do that. You can be going 99% of the speed of light, throw a light beam forward, and someone outside still measures the light going exactly light speed, not faster, the same, always. Light speed is constant for everyone everywhere, always. This one rule breaks time completely. Because if light speed is fixed, if the universe is protecting that number no matter what, then something else has to give. And that something is time. Okay, imagine time is like a piece of stretchy dough. When you're sitting still, your dough is normal. 1 second per second. Boring, fine. When you move really fast, close to the speed of light, your dough stretches. Your seconds get longer. To you, nothing feels weird. But to someone watching you from outside, your clock is going slow. This is called time dilation. And here I need you to hear this very clearly. This is not a theory. This is not philosophy. We have tested it with real clocks on real planes and real satellites. Time actually physically measurably runs slower when you move fast. GPS satellites orbit at about 14,000 kilometers per hour. Fast enough that time runs slightly slower for them due to speed, about 7 microseconds slower per day. They also orbit high up with less gravity, which makes their clocks run faster, about 45 microseconds per day. Engineers correct for the difference constantly. If the GPS satellites didn't fix their clocks every day to account for Einstein's time stuff, your Maps app would be wrong by 11 kilometers. Every day. 11 kilometers. You'd ask for the nearest coffee shop and end up at a different postcode. Relativity is not abstract. It is the thing between you and getting very lost. And gravity does the same thing. Mass bends space-time, and that bending slows time. The stronger the gravity, the slower the clock. Time goes slower near heavy things. Time at the bottom of a mountain goes slightly slower than time at the top. We've measured this. With clocks, it's real. Near a black hole, where gravity is so extreme that even light can't escape, time from an outside perspective almost completely stops. An astronaut falling in would appear to freeze at the edge, slowly fading, never crossing. From the outside view, from their own experience, they cross in seconds. Both versions are correct at the same time. Relativity doesn't have a preference. It also doesn't care that this makes everyone uncomfortable. There is no single universal now. Time is personal, always has been. We just didn't notice because we're all slow and squished together on the same planet. Part 4, Quantum Mechanics, the part where reality gives up. Everything so far has been weird, but manageable weird, toddler explainable weird. Quantum mechanics is a different category. This is the physics of the very small atoms, electrons, photons. And what it says is so strange that I'm going to start by quoting the people who actually invented it. Niels Bohr, one of the founders. Anyone who is not shocked by quantum mechanics has not understood it. Richard Feynman, arguably the greatest physics teacher who ever lived. If you think you understand quantum mechanics, you don't understand quantum mechanics. Werner Heisenberg, who wrote the first complete version of the theory, said the maths works. Nobody knows what it means. The people who built quantum mechanics said they didn't understand it. We've been using it to build technology for 80 years. Everyone just agreed to keep going. Okay. You know how if I hide a toy under one of 2 cups, the toy is definitely under 1 cup. You just don't know which. The toy picked a cup. There's a right answer. You just haven't looked yet. Quantum mechanics says no. Before you look, the toy isn't under either cup. It's under both cups at the same time. For real, not pretend. Both. Until you look. Looking makes it choose. This is called superposition, and it's not a metaphor. At the quantum level, particles genuinely do not have definite properties until they're measured. An electron doesn't have a position. It has a smear of all the possible positions it could be in. Measure it, and it snaps to one. Before you look, no answer exists. After you look, one answer exists. The looking creates the answer. The universe was undecided until you forced it to pick. Erwin Schrödinger, also a founder of quantum mechanics, apparently having the worst time of anyone involved, invented a thought experiment specifically to show how ridiculous this is. Okay, imagine a cat in a box with a machine that might poison it based on whether a tiny quantum thing happened or not. Since the quantum thing is in superposition, both happened and didn't happen, the machine both fired and didn't fire. So the cat is both alive and dead at the same time until you open the box. Schrödinger made this up to prove quantum mechanics was obviously wrong. He expected everyone to agree and fix the theory. The physics community's response: yeah, that's right. Thanks, Erwin. We're putting this in every textbook forever. Schrödinger invented the thought experiment that he hoped would destroy the theory. It became the most famous illustration of the theory. He accidentally made the meme that validated his opponents. This is the most catastrophic own in the history of science. And then there's entanglement. Two particles can become linked, entangled, so that measuring one instantly determines the state of the other, no matter the distance. Okay? Imagine magic gloves. You split them up, send one to Tokyo, keep one here. You look at yours, it's a left glove. The one in Tokyo is instantly a right glove. Right now, no waiting, no message sent. Just instantly. Now imagine the gloves didn't have a handedness until you looked. That's entanglement. The gloves weren't left or right until someone checked, and the moment one got checked, the other one instantly knew what to be. We've tested this at over 1,200 kilometers distance. One particle measured in a lab, entangled partner somewhere else. Measure one, the other snaps into a correlated state instantaneously. No signal, no delay. Just instantly. Einstein spent years arguing this couldn't be real. He called it spooky action at a distance. He proposed that particles must have hidden properties, like pre-agreed instructions, that determine outcomes in advance. Physicist John Bell devised a mathematical test in 1964 to settle this. The experiments ran. Einstein was wrong. No hidden instructions. Just spooky. Genuinely, measurably, irreducibly spooky. The universe is non-local. Measurement here instantly affects things over there. You cannot use this to send messages because the results look random. You need a regular phone call to compare notes. The universe is spooky but inconvenient. Despite all of this, despite nobody fully understanding what it means, quantum mechanics is the most accurate scientific theory ever created. Predictions confirmed to 11 decimal places. More precise than measuring the width of a human hair across the Atlantic Ocean. Every transistor, every laser, every MRI scanner,
every LED screen, every computer,
all built on quantum mechanics. We built the entire modern world on a theory that its own founders said they didn't understand, and it worked perfectly. This is either the most inspiring or most terrifying thing about science, possibly both. Part 5. Where did all this come from, and how does it end? Right. Where did all of this come from? Truth is, we don't know. Matter of fact, it's impossible for us to know. But here is what we know. Okay, imagine everything, all the stuff, all the energy, all the stuff, all the energy, all the future stars and planets and you.
Imagine all of it squished into a dot, smaller than the dot at the end of this sentence.
Now imagine that dot goes boom. Not like a regular boom. Space itself gets bigger. Everything gets further from everything else. Not because things are flying apart. Space itself is growing, and everything is just going along for the ride. That's the Big Bang. 13.8 billion years ago. In the first second, the universe went from smaller than a proton to roughly the size of our solar system. In 3 minutes, the first protons and neutrons formed. In 380,000 years, atoms. In a few hundred million years, the first stars lit up for the first time, and the universe stopped being dark. In 9 billion years, our sun switched on. In 9.5 billion years, Earth formed in 13.8 billion years. You, watching this, having your brain slowly melted. 13.8 billion years of cosmic evolution, and it produced you, watching YouTube. Honestly impressive, kinda what you would expect from a god. Now, the ending. The universe is expanding. We knew that. But in 1998, astronomers discovered something that shocked everyone. The expansion isn't slowing down, it's speeding up. Something, we call it dark energy, which is scientific for this, is definitely real. And we have absolutely no idea what it is pushing everything apart faster and faster. Fact, dark energy makes up 68% of the entire universe. We have never directly detected it. We only know it exists because of what it's doing to everything else. 68% of everything unknown. Also, there's something called dark matter, invisible stuff that makes up 27% of the universe. We can see its gravity, but we can't see it. And all the normal stuff, planets, stars, you, me, everything anyone has ever built or discovered, that's only 5%. We understand 5% of the universe. The other 95% is labeled dark and unknown. We named it dark because we can't see it. We couldn't think of a better word. This is where physics currently is. To be fair, 5% is better than nothing, and it's an extraordinary 5%. But still, long run, stars burn out over trillions of years. Black holes evaporate. The universe cools to absolute zero, cold, dark, silent, forever. But that is so unimaginably far away that it means nothing as a concern. The sun has 5 billion years of fuel left. Right now, today, this is the most complex, structured, alive moment in the universe's entire history. Right now is the good part. You're in it. By cosmic accident. Don't waste it.